Hola, me llamo María del
Hello,
Carmen Alonso.
I am María del Carmen Alonso and I work at the Photovoltaic Solar Energy Unit at CIEMAT with my colleagues Félix García and José Pedro Silva. Together we have gathered the materials to be discussed in this course on photovoltaic energy in order to show you the fundaments, possibilities and technical characteristics of this source of energy.
Photovoltaic solar energy is one of the renewable energy sources that has seen the greatest growth in recent years. This is partly due to the increases in the price of crude oil, leading to interest in alternative energy sources, and also to the setting up of national programs aimed at promoting renewable energy sources. These programs have stimulated the establishment and growth of both an industry able to supply the components of photovoltaic devices and the interest of many people in installing photovoltaic solar energy. All this has generated improved technology for the production of the different components involved in this way of obtaining energy, together with an increase in efficiency and a reduction in prices. To a large extent, this growth has enabled an economy of scale to be established with a consequent reductions in price. Another important issue related to photovoltaic energy is that it is one of the energy sources with the lowest environmental impact, especially in comparison with traditional energy sources. Although nearly all energies can eventually be traced back to solar radiation, renewable energies, and in particular photovoltaic energy, are characterized by performing some kind of conversion. In the case of photovoltaic energy, this entails the conversion from sunlight into electricity. As you know, both in Spain and in Latin America and the Caribbean countries, there is lots of sun, the source indeed of all energies. At industrial level, the development of photovoltaic installations connected to the electricity grid has been spectacular, although autonomous systems are still of interest in off-grid zones. Globally, the total potential installed has risen from approximately 1,500 megawatts in 2000 to nearly 70,000 megawatts in 2011. In particular, in Latin America and the Caribbean, this has great future potential because there are many areas that receive solar radiation in excess of 20,000 kilowatt hours per meter squared along the year. Although all the countries in this area have made considerable efforts in this direction, currently activity is centered on Mexico, Peru, Chile, Argentina and Brazil. The rapid development of the implementation of solar power plants has also contributed to an increase in the feeding of power to national grids. This is excellent news in terms of sustainable development, for decreased dependence on traditional energy sources, and for increased economic activity at local and national level.
The competences to be developed in this course are divided into 5 large thematic blocks. We shall begin by addressing the fundaments of photovoltaic conversion and the fundaments of the devices employed. We shall then look at manufacturing and the ways in which these devices can be coupled to build what we know as a photovoltaic generator. Once we have seen these aspects, we shall explore the fundaments of solar radiation and the variables involved in the assessment of this resource. Study of the characterization of solar radiation is crucial if we are able to assess the energy production of photovoltaic systems. Having looked at the basis of photovoltaic conversion, the generation system as a fundamental element, and with notions about solar radiation, we shall then analyze the remaining components of photovoltaic systems, components that are not part of the generation system, such as energy storage, the systems involved in adapting the current, and the possible loads or typical levels of consumption. We should recall that, unlike other systems, in the case of photovoltaic energy, many very diverse configurations can be used, depending on the application required. In general, these can be divided into 2 large groups. On the one hand, we have autonomous photovoltaic systems, which are generally not connected to the grid, And on the other, we have on-grid photovoltaic systems, which inject excess energy back into the electricity grid. Regarding the characteristics and particularities of these two large groups, the components and different applications will be seen in the last two thematic blocks of the course.
One of the components of photovoltaic systems that has undergone noteworthy development in recent years is the support structure. This development is reflected in an increase in versatility. First, the possibility of using supports for photovoltaic systems in different places and for different applications, and second, an increase in the charge capacity, which is especially related to large plants where larger groups of panels are installed on the same support. There has also been a notable increase in the resistance of the supports of solar panels to different climatic conditions. And finally, the movement of the supports when following the sun has been finely tuned, improving the yield of photovoltaic solar energy. Another important aspect that has undergone development in recent years and continues to do so is legislation. Current legislation enables us to demand that the various components of a photovoltaic system be in accordance with the requirements that aim to guarantee the quality and, above all, safety of photovoltaic systems. This is evidently to the benefit of the final consumer, but also of the installers, the distributors, and the manufacturers of photovoltaic components. Other important aspects in the legislation are not only related to the components themselves, but also to procedures aimed at regulating the calibration of the instrumentation used in testing laboratories, as well as their legislative norms and the accreditation of the different testing laboratories working with photovoltaic solar energy.
Y de este modo hemos pretendido facilitar al alumno un acercamiento.
So you can see that we are trying to focus on offering you a global approach to photovoltaic solar energy. Our aim is to suggest a general guide to the material
como unos recursos válidos para la determinación de diversas
and also some valid resources for the determination of the different calculations to be made in the field.
Por ejemplo, el dimensionado de los sistemas y componentes fotovoltaicos. Para ello,
examples are the dimensions of the systems and photovoltaic components. Accordingly, we wish to emphasize both the developments made in the theoretical basis of photovoltaic solar energy and the tools and mathematical formulas required to perform the calculations with reasonable precision.
We hope that the view of photovoltaic solar energy offered here will awaken your interest and stir your curiosity about the huge opportunities to be gained from this energy source. We also hope that we can contribute to the formation of a team of people committed to sustainable development and the diversification of energy sources. Thank you very much.